In this video, we're going to take a look at a concept called ISIS leaking, which allows us to take more granular information from, the level 2 areas or potentially a remote level 1 area, and allow that to be sent into, in this instance, area 49.001, so that it is visible on OR5. Now, OR5 is a level 1 only router, so it doesn't have, by default anyway, visibility or specific visibility outside of its own area. The level 1-2 routers, OR1 and OR3, are going to create LSPs with the attached bit set, which OR5 will then generate a default route and point it at one or both of them, depending if they're working. We'll see OR3 is not working and how we can identify that. First off, let's take a look at router 5. For ISIS, and we have 4 prefixes in there at the moment. We have our default route. We have 3 other prefixes, all from OR1. We have 10.1.2.0 and 10.1.3.0, which is the point-to-point link from OR1 to OR2 and OR3, respectively. And we have finally 10.10.10.1, which is the system address of OR1. And the reason we have a default route lies in the database. We see here the LSP from router 1 has the attached bit set, which allows OR5 to create a default route and point its next hop to whatever the next hop is to get to router 1. In this instance, it's directly connected, so the next hop is 10.1.5.1. Over on router 1, let's just make sure that we can see outside of the area, and we've got loads of prefixes. Now, the prefix we're interested in this case is 198.51.100.2/32, which is a loopback address injected into ISIS over on router 2. Back on OR5, let's check our adjacencies. As I said, there's a problem with 3, so we only have an adjacency to router 1 at the moment, and it's level 1 only. And the reason it's level 1 only is because I have configured it as a level 1 capable router only. Okay, so this is never going to attempt or allow a level 2 adjacency to form. Now, OR5 sees multiple prefixes from router 1, as we saw. Why do we see that? Isn't it supposed to just be the default route? Not necessarily. If we see the interfaces that we've enabled into ISIS and OR1, we have the first 3 here. System addresses are level 1-2, which is the default interface setting, and the router interface to OR5 is explicitly configured as level 1 only. So these guys are going to appear in the level 1 database as well as the level 2 database. Because of that, we're going to see them in the routing table over here on OR5. Now, we can get rid of them if we want to. The power is in the hands of router 1. So let's get rid of interface 2 OR2, and all we need to do is change the level capability on that to level 2 only. The interface capabilities have now changed to L2, and that prefix should have disappeared now from the routing table, and it has. So down to business, we want to take the 198 prefix from OR2 and we want to throw it into area 49.001, and we make this change on the ABR, or the L12 router in ISIS lingo. So first we have to create a router policy, and depending on the level of code you're running, of SROS or TIMOS, you have to type in policy options. This is not something I'm a fan of. Small things, but whatever. We're going to create a prefix list to match this particular prefix and match it only. I don't want any other information leaking in. So we'll say loop OR2, and the prefix is 198.51.100.2. And then we have to create a policy statement, and let's cause leak to 49 even 001. Entry 10, entry whatever you want to pick, and we're going to say from prefix list loop OR2, but also from level 2. So we're saying if this is in level 2, we're going to allow it into level 1 and do an accept action against that. And we leave everything else as default because we don't want any other prefixes getting in with a blanket implicit or explicit allow all. So we commit that configuration and we go into IS to IS and we configure it as an export policy, leak to 49 treble 01. Now that prefix should now appear in OR5. There you go. If I wanted to allow anything else in, let's see what else we have available. How about router 6's prefix? We take that as well. So all we need to do in that instance is go back into our policy, prefix list loop on OR2, and add in the prefix. Commit it. Now OR5 should have that as well, and it does. Now over on OR5 we see we have a preference of 15. That's because this is a level 1 only router. OR2 is going to see that as a preference of 18 because it's learned from an L2 router, in this case from OR2. So can we ping it? Source from our system address 10.10.10.5, and we can. What else do we have over here? 66. Okay, so 66 lives in the same router as 6. Are we able to ping that? We shouldn't be. Well, we should be actually at this stage. We can. So what we need to do if we want to filter this out is we need to get rid of the default route. Now, depending on the release of software you're using, there is an option to suppress the attached bit. So once we do that, the database on router 5 is going to change. The attached bit will have disappeared out of the attributes, and router 5 is not going to be able to ping that address now. No route to destination. So we don't have an explicit route. We also don't have a default route to follow. Obviously not a good design, but it illustrates the point. Now, maybe we want to use OR3 for our match the default route type traffic. We want to have specific leaking on OR1, and then everything else is going to go over OR3. So does OR5 have an adjacency first? It doesn't. Does it have an interface to OR3 in ISIS? And it does. Is it able to ping? Ping all the things, yes. So now let's take our investigation over to OR3. It also has the interface enabled into IS to IS. So we need to determine what's going wrong here. So we will use debugs. Debug router IS to IS packet. We're going to tell it to use a particular interface, otherwise it can become quite chatty. And if you're not too used to the format of IS to IS output, it can become overwhelming very quickly. So we're going to say detail and then turn debug off. Okay. So we've received a PDU, protocol data unit, and we can see the area address that we've received it from is 49.003. So because OR5 is level 1 only, it has to match the area of a potentially adjacent router. Because OR3 is in 49.003, it's not going to work. So we can see here it's configured as area 49.003. So we need to change that. So OR3, we're going to say area 49.003, 49.001. See, we now have both. We can have 3 by default. So now we take out 49.003 and it's disappeared. Good stuff. So now we should see an adjacency up here on router 5. Maybe give it a minute. Let's turn on our debug again. So quiet. Do-do-do-do. So the area address is correct now. So what else could be wrong? We have a point-to-point hello, so it's correctly set to be a point-to-point interface. The circuit type now over on router 3 in the received PDU we see is level 2. So we have to change that as well. So here under OR5 we go, well, it's not explicitly set as level 2. Why is that happening? It's because we've set it at the global context of IS2IS. So we need to tell IS2IS that it is a level 1-2 capable router, and then we'll see it come up on router 5. So now we should have our default route from router 3. Lovely stuff. There it is. So now we check our routing table over on OR5. We see we have our default route via router 3. We have our more specific prefixes via router 1. So if we trace to them, let's say 192.198 even, 51.100.2, that should go 10.151 and over to 2, and it does. If we trace to 66, which we don't have an explicit route for, this should go via router 3. And it does. So it goes 3, 1, 2, and then on to OR6.